Okay, hello. I am very excited for this coding challenge. This coding challenge is dedicated to all the new YouTube sponsors. I don't know, in the future when someone's watching this video, YouTube won't even exist or sponsors, but it just happened today and all these people are sponsoring like Wow Wow Tomika. Thank you. Okay, what am I going to do in this coding challenge? So this was my previous coding challenge, the water ripples coding challenge. I made some fixes to it, by the way. Had some errors in the code. You can find it on GitHub. And this is just showing you the water ripples where I'm placing them randomly instead of moving the mouse around. And I didn't realize this. You can see this is called fire ripples because I've already set myself up. I was not aware of this, but Hugo Elias, there was another algorithm, a fire algorithm. And this is explained in great detail here. And so I'm not going to read the whole thing over. I encourage you to read it over. I'm just going to try to implement it. But what's really cool about this, just look at it really quickly, is it works if you create this thing called a cooling map. So I'm going to create a cooling map, I guess like this, that's just kind of noisy and grayscale-y and smooth. But you can make shapes and patterns or use an image. I think this is going to spawn a lot of creative ideas. So let's get started making this. So I'm actually going to just start with my code base from before because it has most of the same things that I need. And so if we start here, the flames can be made to start anywhere on the screen by simply sprinkling a few pixels. Most implementations had the flame source at the bottom of the screen. By the way, where does this algorithm come from originally? I don't know. I'll have to read this page over. I got to do this coding thing. Okay. So let's go here. So first thing I want to do is I'm just going to kind of get rid of the swapping algorithm, and I think I'm gonna just get rid of this, and I'm gonna just have one array, which is actually, here's the thing. I think I can just use the pixels itself. It doesn't look like, oh, this is the smoothing. Yeah. So I'm looking at this. Yeah, but I need a current index. I need a buffer. So, but I think this might actually make more sense for me to do with image buffers. So rather than have these two-dimensional arrays, let's try something. I'm just getting rid of everything. Well, this is a nice idea. Let's do this. So much for starting with that code. All right, what I'm going to do is I'm going to create a p image. I'm going to just call it buffer1. And I'm going to say buffer2. And buffer1 is going to be an image that's the same size as the window. And it's an RGB image. Buffer2 is the same thing. And then just what I just want to do, I just want to put a bunch of pixels at the bottom that are white. So I want to say int x equals 0, x is less than buffer1 dot width, x plus plus. I'm going to say buffer1 dot pixels. And so one thing that I really need, I have a bunch of image processing videos about this, is I always need, if I have an x and a y coordinate, I need to find the location in this array, and the formula for that is int index equals x plus y times width. In this case, the y is the last row. So y equals buffer1 dot height minus 1. And you know what? The width and height are going to be the same for everything, so I can just use the global variable. Whoops. So this is the y. And so now buffer1.pixels y index equals color 255. Okay. So let's look now. And I'm going to say buffer1 update pixels. This is just how I'm getting things started in setup. Buffer1 load pixels. And then I'm going to say buffer1, I'm going to draw that image. Image buffer100. So, and let's actually do, I kind of want to do this well, let me just run this. So yeah, you should see, it's hard to see. If I made it red, that would make it easier. Like, let's make it red. you can see that there's a red line at the bottom. So that last row of pixels is full. So this is my starting point. So now what I want to do is I need to apply this smoothing step. There are a few ways to do this depending on exactly how you want to smooth the image. So I could probably do all sorts of fancy smoothing algorithms and Gaussian blur and all that, but this is a nice way of just adding up, applying a convolution, right? A little matrix, adding up the pixels and its neighbors and dividing by 4. So I'm going to say, and I'm going to use buffer 2 for that. So buffer 2 equals, oh, no. I need to loop through all the pixels. Let me give myself some space down here. So I'm going to now have an algorithm that goes through all the x's. And it goes through all the y's. And I'm going to skip the edges. Which I might need to think of, be more thoughtful about this later. Okay, so now what I need to do is let me get the color. I'm going to get the color from buffer 1 pixels at an index, and that index is the same as this formula. So that is now the color. So then, oh, actually don't need to, I need to get all the neighbors. So this is going to be a very awkward way of doing it, but I'm going to do it this way anyway. I could do another loop inside here, but I'm going to do this really manually. And then so y plus 1, y minus 1, and let me put the print, just to be consistent. This is totally just my own, like wanting to be consistent here. So look, these are all of the neighbors. X plus 1, x minus 1, y plus 1. Not all of the neighbors. All of the neighbors, only the 2 neighbors to the right and left and the 2 neighbors to the top and bottom. I'm not doing the corners. So this is really simple. And so now I need to get all of the colors. And again, I could do this with, like, apply a convolution in a more thoughtful and creative way, but I'm just going to do it this way. And now what I need to do is I want to get a new color, which is equal to the brightness of C. I'm doing everything in grayscale right now. So I'm going to add up all of these. Oops, plus C3 plus C4. I'm going to add them all up together. Then I am going to, let me see, I'm going to say buffer 2 pixels, and I do want that index. The regular index, we'll call that index 0, will just be x plus y times width. At index 0 is a color with the new value divided by 4. Or I think I might like to say multiply by 0.25. So I've now implemented this part of the algorithm, right? And I think I need to put it in a separate buffer because I don't want to overwrite the image that I'm using now, right? And then continue to use those pixels. So everything will get all messed up. So after that's done, I should be able to say buffer 2 update pixels. And I don't need to draw this here. I need to load the pixels of both of them because I'm working with both buffers. And then I need to swap them. Swap. So I need to say p image temp equals buffer 1. Buffer 1 can become buffer 2, and buffer 2 can now be what was buffer 1, which is stored in temp. So now if I run this, we should see it's going to it slowly blur away. What if I continue to always add a line. So let's write this a function like, let's write a function called fire, which what it does is in buffer 1, it adds a row of red. Oh, and let me actually just make it white because I'm not dealing with color yet. And let's actually call that at the beginning of draw. So let's do that over, and let's always reset the bottom one down to red. All right, what am I doing wrong here? Oh, I'm back. I forgot to draw the image. I forgot this whole time, I forgot to draw image. So let me draw buffer 2. Yeah, this is what I expected. We're seeing this sort of like blurring of the pixels moving up. Okay, there we go. So we can see that that's actually happening. I really would like to do this with the RGB values, but that's going to add too much to this right now, so I'm not going to worry about that. Okay, so now, so this is the heat spread. Cooling is simple and involves subtracting a small amount from every pixel. The exact amount depends on how quickly you want the fire to cool. Well, let's say I don't want it to cool at all. Let's skip the cooling for a second. Let's go to convection. Scrolls the image up by a pixel or two. So where is copy buffer 2 to the screen, copy buffer 2 to buffer 1, scroll cooling map up 1 pixel. Smoothing and convection into 1. You are indeed correct. Any programmer worth their salt should see that. I am not worth my salt. I did not see it, so that is where I'm going to leave it. What? What? That's not very helpful. What I want to explain is how to make the fire look really good. And incidentally, in this next method, okay, uneven cool. All right, so I'm gonna let's create the cooling map. All right. Okay, so let's look down here, and aha. So this is actually where that convection is happening, right? I could actually just write the pixel to 1 row higher, and that's what's going to move it up. Now I'm not adding the cooling yet, so I've got this here, but really I just need to like write it to scroll it up. I just need to like change this index 0 to this one should actually be y minus 1. So in this case, it's really the same as index 4, right? That's the same as index 4, but you know, why not have it as a different variable? So now if we run this, we can see, there we go. Look, the fire is burning. Now, interestingly, I expected it to overwhelm everything, right? Because I don't have the cooling in there. What am I doing wrong here? Brightness, 1, 2, 3, 4. Let's just check this. This is actually no point in doing this in draw because I'm never actually iterating the bottom pixels. Oh, you know what the problem is? No, actually, I do need to do that because I'm swapping. No, buffer 2 never gets. So actually, if I want to be sort of thoughtful about this, I should just always have in both of them right? Because I'm swapping the memory back and forth. And so like the bottom should always just be a row of white pixels. And then I need to make sure I set that up at the beginning. Same thing. So what? I guess maybe I should do two rows of white pixels. So let's do this twice, just to sort of test this idea out. There we go. This is more like what I was expecting. Okay. So there we go. So this looks more, I just didn't really give myself enough white pixels at the bottom. So now this is just filling this up. I'm not seeing any fire. So let me be a bit more thoughtful about this. So I'm going to actually give this a set of rows, and I'm going to say I'm going to have another. I'm going to use I and J here. Actually, I'm just going to use J as the second one. J equals 0. J is less than rows. J plus plus. And then Y is equal to height minus J. And I think I should be able to get away with just putting it in buffer 1. So I'm always going to add some white pixels to buffer 1. So I'm going to say fire 2. Let's look at this. Y equals height. Oh, this should be height minus j plus 1. All right, there we go. Okay, so that's the fire growing up from the bottom with setting 2 rows. And now if I want to set like 5 rows to white to like have more fire, you can see it's sort of mostly the same effect. 50, but you can see, that's just how much white I'm putting there on the bottom. All right, so this is the fire burning. Now, the exciting part is coming now. What I need to actually do is this cooling. I need to create a cooling map. Now, does this look like anything familiar to you? I mean, I could make something in Photoshop. I could design a shape. I could have RGB. There's so much I could do. But this looks like a Perlin noise field to me. So let's quickly make a Perlin noise field. Let me find in examples under basics, under math. Look at this, noise 2D. And now I'm going to grab all of this. And I'm going to put this into the cool function. But I want this to all be operating under cooling. So cooling is another image. Look at this. It has the same number. It has this. Isn't that a beautiful thing? It has the same number of characters as buffer 1 and buffer 2. So it's another one of these images. Then the cool function, I'm going to say cooling.load pixels. I'm going to forget about noise detail and just let it be the default settings. I do need an increment variable. I don't know how I lost that. Let's make that point. What was it in the example? Oh, I already closed it. Open recent maybe? Yeah, there we go. Oh, 0.02. Let's use that. 0.02. And there we go. Now I'm just going to say cooling.pixels, cooling.update pixels. Let's comment out drawing the actual buffer, and let's just draw cooling now. So let's look at our cooling map. There we go. So that's the cooling map. There it is over there. And I could play around with this by changing the increment value or blurring it or changing noise detail. I'm just sort of curious. Let's make this 0.1. But so good enough, right? So I'm going to leave that as my cooling map. Then I'm going to switch to showing buffer 2. And now I just have one more thing I need to add. In here, what I need to do is subtract the pixel from the cooling map. So all I have to do here is now go and say, all right, color C5 equals cooling dot pixels. Here we go. So actually, I really do want index 0 because I want to, right, when I, subtracting it from the cooling map is actually at xy, right? This xy minus 1 is just for sliding everything up. So index 0 should actually be this. And then secretly, I'm going to use index 4 here. And then here, I'm going to use index, index 0. And then I can say, and we could call this P, right? Why not? And then P equals P minus C. Oh, no. P equals, sorry, new C is that. This is C5. Now new C equals P minus C. So that is new C minus the brightness that's in C5. Now my naming here is horrible. I think I should maybe when I post this code, I might rename a bunch of these variables to make it more clear. But now we should hopefully see. It looked like it did something there, but someone in the chat just said that your cooling is too high, which is probably the case. So let me look at how I'm making this, and let me just make these much less bright. Yeah, but why? Oh, you know what? I think it's fixed. So it is like fiery, but it's not. It's fixed because I'm only ever adding the exact same amount of the exact same amount of kind of like white to the bottom every time. And it might actually, I probably want to add fire more in a more kind of random way. Perlin noise was a nice idea. The problem is Perlin noise, even with me ramping it down to 100, is you need to have some black gaps. Like I need just much, much less white in the picture. So I think what I'm going to do is I'm going to do something like this. And then I'm going to say if n is less than like 0.4, just set n equal to 0. Actually, you know what would be useful is for me to, say 1200 by 400 and have width equals 600 and just keep track of these in separate variables. Because then if I do that, I can look at them both. Whoops. Something went wrong. Oops. There we go. So I can look at the cooling map next to the fire. I need to scroll the cooling map. I need to look at the chat. It's cooling map by a pixel. Oh. Oh! Look what the train just brought in. More instructions about the algorithm that I didn't bother to read. Scroll the cooling map up 1 pixel. Guess what? I could do you even better. Because it's Perlin noise, oh boy, this is exciting. Because it's Perlin noise, I can actually have y off. I'm going to call this like y start equals 0.0. The y offset is going to start at y start, and then y start is always going to also go up by increment. And so now, if I call cool in draw, we should see this scroll. That looks sort of more, this is kind of crazy what I'm doing. Okay, so a couple things now. Let's see if setting the Perlin noise back to something much brighter makes sense. And maybe I don't need to set so many rows. This looks much more like fire in an interesting way. And also, maybe I don't need to worry about this capping thing so much. I was too worried about that. It's still much too white, much too bright, right? It looks a little bit more like fire now down there. And now I could try, let's make this less bright. There we go. Look at my fire effect. I also feel like it's kind of slow. Let me, where's my cooling image? Let's make this even less. There, what do we think? Kind of fiery. Now, so there's a lot of things you could do here now with this. You could add color. You could be more clever about how you make the cooling map with shapes and things in it. Let me show you one avenue that you might not be thinking about. I think something that could be effective here is let's just think about this fire thing. I have to set pixels to white in order to start the fire. I did start the fire. We didn't start the, anyway. So what if though buffer one were not a P image, but a P graphics object? Let's just bear with me for a second. I'm going to say create. Oh, these are all going to have to be graphics objects if I'm doing this. At least buffer one and buffer two. So let me make buffer one and buffer two P graphics objects, because these, and then I don't need to specify RGB, but I do need to, however, I believe say buffer one begin draw. So I'm about to work with the pixels, and buffer, with the graphics I have to specifically say begin draw and end draw in addition to load and update pixels. And so here, I think I'm going to have to say that for buffer 2, begin draw, because I'm operating on the buffer 2 pixels. Buffer 2, end draw. Let's just see if this is exactly the same. Oh, and this has to say P graphics. So this should be the same. Okay, it's the same, but I've done something really exciting here. Because what I could do is I could now also say, I could add mouseDragged. And in mouseDrags, I could say buffer 1, begin draw, buffer 1, end draw, and I could say buffer 1, I could say buffer 1 dot, now I can do anything that's in the processing API. I could say fill 255, buffer 1, ellipse, mouse X, mouse Y, 100, 100. And actually, let me make this mouse pressed. And let's see what happens here. So now when I click the mouse, oh wait, there we go. Look what happens. Oh, that is wild. So hold on, let me swap where these are being drawn. So now, right, anywhere I click, it kind of it starts the fire there. So let me make this mouse dragged. Oh, and let me get rid of the stroke. Buffer 1, no stroke. So you can see I can kind of like seed the fire however I want. Now again, I'm just adding circles. So now the whole world is open to you. You can create your cooling map in an entirely different way. Just to remind you, this is what my cooling map looks like. But you don't have to use Perlin noise. You could actually have shapes in here. Now you could make this a P graphics thing and draw into it and blur. Somebody suggested an elephant, so you could make a sort of flaming elephant. Don't set the elephants on fire, anybody, please. Be nice, be kind to the elephants. But you should see you can start the fire on the bottom. You could add fire by drawing with the mouse. There's so many possibilities here. So I'm done with this. I want to see your creative variations. I want to see your versions that use full color RGB, and I want to see your versions that cleverly like incorporate shapes and text and other types of imagery. So make them into GIFs, tweet them, hashtag coding flames. I don't know. Dare I look, twitter.com/hashtag coding flames. All right, I think we're good. No results for coding flames. So code your flames and enjoy. All right. I'll see you in a future video. Thanks for watching.